Tantor Audio, a division of Recorded Books, presents The Genesis Quest, the geniuses and eccentrics on a journey to uncover the origin of life on Earth, by Michael Marshall. Narrated by Ciaran Saward. Publisher's Note: this audiobook includes bonus material. Please visit tantor.com and type The Genesis Quest into the search box. Follow the link to the book's page, then, under the supplemental content section, please enter the access code BIRTH, and then click the Unlock button to access the bonus material. The code should be entered in all lowercase letters. All figures and tables referenced in this audiobook can be found in the bonus material.
Introduction. How did life begin? Why are we here? These are among the most profound questions we can ask. They are about both ourselves and our relationship to the wider universe. Yet while the question of how life started on our planet is an obvious one, scientists only really began engaging with it in the early 20th century. Research into the origin of life is barely a century old. Even today, there are only a few dozen laboratories that directly tackle this important subject. This audiobook is the story of the scientists who have attempted to explain how and why life arose on our planet. It explores all the major ideas, explains how the scientists came to develop them, and delves into their strengths and weaknesses. It is crucial to tackle all the ideas, because, despite what their proponents say, it is clear that most of them cannot be correct. It is only by trying them all on for size that we can start to see how life might really have begun. In recent years, origins researchers have started to devise a kind of grand unified theory that has a good chance of being correct, in part because it includes the best elements from the older ideas. It is only by examining what has gone before that we can unlock the secrets of what might come next. Our story begins in the 1920s, when, after decades of minimal progress, a scenario was proposed that gained widespread acceptance, that life began in the famous primordial soup. However, little progress was made for decades until a seminal experiment performed by Stanley Miller in the early 1950s seemed to show that the chemicals of life could have formed naturally on the young Earth. The Miller experiment kick-started a new field of science called prebiotic chemistry, which sought to make life's building blocks from simple chemicals. However, the problem of life's origin swiftly became immeasurably more complicated, thanks to the emerging knowledge of the complex workings of living cells. So intricate and interdependent is the machinery inside even the simplest bacterium, it is hard to imagine what a basic, primordial version would look like. Strip out even one of the key systems, and the organism dies. As a result, from the 1960s on, several competing ideas arose, each championed by a faction of scientists for the remainder of the 20th century. Each of these new ideas focused on one key component of living cells, which was supposed to arise on its own, and then bring the others into being as necessary. For example, one popular idea, known as the RNA world, holds that a simple genetic molecule came into being and found a way to copy itself. Unfortunately, all these ideas ultimately fall down. None of life's components, on their own, can achieve living status. However, in the 21st century, a few researchers have begun exploring ways to build living cells with all the key systems intact, but in hugely simplified form and using a bare handful of chemicals. This new approach, which was long viewed as virtually inconceivable, has had an astonishing run of success. The earlier ideas are still much discussed, but the new hypothesis has a better chance of being correct. It now seems that life began not with a single component, like a gene, but with several components that could work together. Life is less about a particular substance and more about the way a group of substances behave when they are combined. The quest to understand how life began is also the attempt to answer a profound question. Is life inevitable? That is, was life always going to form, given how the universe works, or is it a freak accident? In his 1970 book, Chance and Necessity, the French biochemist Jacques Monod staunchly argued that the universe is not shaped for life like us. He contended that the origin of life on Earth was stupendously unlikely. Life may only have formed once, here, in the entire history of the universe. The universe was not pregnant with life, nor the biosphere with man, he asserted. Is it surprising that, like the person who has just made $1 million at the casino, we should feel strange and a little unreal? Monod's attitudes were evidently shaped by existentialist philosophers like Jean-Paul Sartre and Albert Camus, who wrote of their nausea and alienation at a life lived without the moral compass offered by a god. He argued that we should all now feel alone in the unfeeling immensity of the universe. Monod's high-flown rhetoric has impressed a lot of people over the years, but aside from his portentous prose, he offered precious little evidence. His main argument was that the evolution of a new species is ultimately driven by random changes in genes. This meant that the sole driving force of evolution was pure chance, absolutely free, but blind. However, Monod arguably went too far. It is true that genetic mutations are random, but which ones survive and become common in a population is not necessarily random at all. Instead, the mutations that survive are those that bestow benefits on the organisms that carry them, or at least allow the genes to become more common. That is why certain traits have evolved more than once, with different genetic underpinnings. For example, flight arose independently in insects, birds, and bats. Monod was looking at the history of life through random-tinted glasses. It is a mistake to overemphasize the randomness of evolution and neglect its many regularities. Let's now consider the opposite viewpoint. Origin of life researchers often say that life was somehow predestined. This can come across as semi-mystical, but there is at least some basis for thinking it is true. The person who argued most fiercely that life was inevitable was the Belgian cell biologist Christian de Duve. In his book Vital Dust, he argued that life is a cosmic imperative. Given how complex living organisms are, de Duve argued, they are stupendously unlikely to have arisen by chance. We are being dealt 13 spades, not once, but thousands of times in succession, he wrote. This is utterly impossible, unless the deck is doctored. In other words, life must be easy to form under the right circumstances, or we would not be here. Over the course of the story, we will see that there are many natural processes that favour the formation of the chemicals of life, and of lifelike structures, which supports de Duve's contention. Ultimately, de Duve's arguments rely on a rule of thumb called the Copernican principle, or the mediocrity principle. The basic message is, assume we are ordinary. Scientists have tried to stick to this ever since astronomer Nicholas Copernicus presented evidence that the Earth orbits the Sun and is not at the centre of the universe, as almost everyone had assumed. The Copernican principle suggests that the chemicals and environments found on Earth are probably typical of rocky planets. In that case, life is fairly likely to pop up on any reasonably Earth-like planet in the right sort of orbit around the right sort of star. However, we should not take this too far. Listen again to the last sentence of the previous paragraph and count the caveats. Life may be likely, but de Duve knew that does not mean it is common, and a glance at the known universe tells us that hardly any of it is remotely suitable for life. Consider the Earth, the only place known to support life. Most of it is utterly inhospitable. The habitable zone is at most a few tens of kilometers thick, spanning the outer layers of rock, the seas, and the lower layers of the atmosphere. Go too high up, and the air becomes too thin, the radiation from the sun too intense, and the temperatures too extreme. Meanwhile, go too far underground, and the temperature and pressure become lethal. Our world may be a living one, but over 90% of its mass is dead. Beyond Earth, things get even sketchier. Even if trillions of planets are home to life, there are still vast volumes of empty space in every solar system, not to mention all the interstellar space and the unimaginable voids between the galaxies. Some of these hollow spaces are hundreds of millions of light-years across. Unless there is life within stars or in the empty blackness of intergalactic space, the universe is mostly dead. It is a good bet that 99% of the volume of the universe is lifeless, as is 99% of matter. It is stretching the definition of favoured quite far to claim that this is a universe that especially favours life. In fact, the whole argument can be turned around. Our universe is egregiously hostile to life in all but a few minuscule patches. If the universe is fine-tuned for anything, it's for empty space, dust, stars and planets. But on at least some of those planets, life is quite likely. Life is an edge phenomenon in the cosmos, something that has snuck in. This perspective is somewhere between the two extreme positions staked out by Monod and de Duve, albeit closer to de Duve. The universe does not look like an engine optimized for creating life, but nor is it wholly bent on exterminating it. Instead, it is largely occupied with other things. Over the course of the story, we will discover special places on the Earth that seem to be ideal incubators for life, and see that those places are rare in the wider universe. As well as a scientific odyssey, this is a story with a fascinating and often brilliant cast of characters, from the rambunctiously eccentric J.B.S. Haldane to the irascible Günther Westershäuser. Many of the people involved have been Nobel Prize winners, and they include some of the most brilliant minds of the last century. Some, like Carl Sagan, are well known. Others will be less familiar. Discovering this unlikely group of pioneers is one of the great pleasures of the story. Sadly, astute listeners will soon notice that most of the scientists involved are male. The first 3 chapters do not contain contributions by a single female scientist. This streak does not break until Rosalind Franklin makes her appearance in Chapter 4, helping to reveal the structure of DNA. Even after that, almost all the key figures are male. This should not come as too much of a surprise, as the institutions of science have been as beset by sexism as the rest of society, as science journalist Angela Saini has exposed in her book Inferior. I have tried to find female origins researchers who have been overlooked, with little success, and have sought to name female co-authors alongside the male heads of lab. But it would be misleading to make the story look more egalitarian than it was. For what it's worth, I hope that future accounts of origins research, written when more time has elapsed, will feature a more diverse cast of characters. Despite these issues of representation, the story of the quest to understand Genesis is a universal one, in which everyone can find pleasure and fascination. By asking how life came to be, we are implicitly asking why we are here, whether life exists on other planets, and what it means to be alive. This audiobook is the story of a group of fragile, flawed humans who chose to wrestle with these questions. By exploring the origin of life, these people have caught a glimpse of the infinite. Michael Marshall, Devon, February 2020. Part 1. Primordial Science. Most chemists believe, as do I, that life emerged spontaneously from mixtures of molecules in the prebiotic earth. How? I have no idea. George Whitesides, in his 2007 address accepting the American Chemical Society's Priestley Medal for Distinguished Service. Chapter 1. The Biggest Question. Everywhere you look, you are looking at life. This is true even if you stare at a brick wall, at a computer screen, or straight up into the sky. Even if there are no big animals or plants in sight, there are insects, microscopic animals, and, always, uncounted billions of bacteria. There is life on every surface of our little planet, even in seething hot geothermal ponds, in the crushing pitch-black depths of the sea, and above the clouds where the air grows thin. But it was not always so. There was a time when Earth was dead, a time when it was a ball of semi-molten rock, blasted by pummeling meteors and dotted with violently erupting volcanoes. There were no seas then, and no oxygen to breathe in the air. If we were somehow to travel back in time to visit this young Earth, without protective clothing and an oxygen tank, the only question would be how we would die first: asphyxiation or simply being incinerated. Somehow, our planet transformed itself from a lifeless hellscape to the green and blue paradise our species is currently in the process of screwing up. What happened back then? What was the first living thing? What did it look like? What was it made of? And how did it come to be? This question taps into another mystery, one that has boggled our minds for centuries. Are we alone in the universe? So far, Earth is the only world known that supports life. What conclusions should we draw from that? Perhaps the formation of life is overwhelmingly likely, given the right conditions, in which case the cosmos must surely be teeming with life, and the other worlds in the solar system just didn't fit the bill. Or maybe life is staggeringly unlikely, something seemingly miraculous that happens only on one world in a billion. In that case, we are alone, existentially so. And when we look up at the stars, we are looking at emptiness. Humans have told stories about the creation of life for thousands of years. These myths can be beautiful and meaningful, but none of them really explains how life could have formed solely from non-living building blocks. To illustrate this, consider the Norse creation myth, which was splendidly retold by Neil Gaiman in Norse Mythology. Gaiman tells of enormous glaciers that extend into a land of volcanoes and fire. Where the ice is melted by the fire, a huge person appears, called Ymir, who is the ancestor of all giants. Alongside Ymir is a vast, hornless cow, who feeds by licking the salty ice. Ymir, in turn, guzzles the cow's milk and grows. This is a vivid story, but it doesn't take much pedantry to see that it doesn't explain anything. If you melt some ice, you don't normally get a giant, let alone a monumental cow. The story skips the difficult part in order to get to the resonant bit, which comes a page later when the god Odin and his brothers murder Ymir, and in doing so, create the world. At least the Norse myth explicitly depicts life coming from non-life. Other creation myths cheat even more spectacularly by saying that life was created by pre-existing life, the origin of which is left as an exercise for the reader. Any story in which life is created by a god, or gods, is guilty of this. The retort, "But where does the god come from?" is so obvious it can seem childish to utter it. But being obvious doesn't make it an invalid question. Once you realize that creation myths don't offer an answer, it becomes clear that for most of human history, nobody was really asking how life began. This seems to be because people had two implicit ideas about the nature of life, which between them closed off the question. The first assumption was that there was something special or magical about living matter that made it fundamentally different to non-living matter. This idea is called vitalism, and it recurs across cultures. It's right there in the book of Genesis. "And the Lord God formed man of the dust of the ground, and breathed into his nostrils the breath of life, and man became a living being." The Stoic philosophers of ancient Greece wrote about pneuma, which means breath, but also implies spirit. Similarly, Aristotle discussed psyche, which means something like soul, but is not necessarily conscious or intelligent. If you believe you have a soul, maybe made of some nebulous energy that will leave your body when you die, then you believe in vitalism. There is something profoundly attractive about vitalism. It seems obvious to everyone that an elephant is not the same thing as a rock, and that difference is not just fine detail, but something fundamental. Life is special. But while vitalism is intuitive, it is also plain wrong. There is no life force. Or if there is, nobody has been able to detect it or even specify what it is. Instead, much of the last 200 years of biology have been about explaining the unique properties of living things in terms of the non-living chemicals from which they are made. The story that is often told about vitalism is that it was disproved by the German chemist Friedrich Wöhler. Historians of science have argued that this is something of a myth, as we'll see, but it remains a crucial episode. By the early 1800s, scientists had identified a number of chemicals that seemed to be unique to life. They were only found in living things and nowhere else. One such chemical was urea, which is found in urine and gives it its yellow-brown colour. Along came Wöhler. In 1824, he was puzzled by some white crystals that formed during a chemical experiment. 4 years later, he identified them as urea. Crucially, he also reported that he had made urea from ammonium chloride, a chemical that has nothing to do with life. However, it is not clear that this really disproved vitalism, or that Wöhler saw it in that light. Certainly, Wöhler's result was bad for vitalism. If it was possible for one of the chemicals of life to be made from a chemical that has nothing to do with life, presumably others could be. However, Wöhler's own discussion didn't really put the boot into vitalism at all. Instead, the idea that Wöhler disproved vitalism gradually emerged in commentaries written by other scientists over the following few decades. This process has been traced by Peter Ramberg, a historian of science, who calls it the Wöhler myth. By the 1930s, one can find descriptions of Wöhler trying over and over to synthesize urea from other chemicals, determined to refute vitalism. This does not seem to be how Wöhler saw it. Setting aside the historical controversy, there is a better reason to reject vitalism. Put simply, vitalism is an atrocious explanation for the existence of life. It does nothing to explain what is special about living things, but merely puts a label on that specialness. If you posit the existence of an undetectable and undefined energy that can turn non-living matter into living organisms, it doesn't explain the existence of life. It just raises questions of what this energy is, how it is generated, and how it can affect the matter in living organisms without being detected by any sensor or experiment. Footnote. This is also the reason not to accept gods did it as the explanation for the existence of life. It explains nothing. If you asked how a car was made and were told, "Someone built it," you would not be satisfied. Let's consider also what it would mean if there really were a life energy or vital substance. In theory, we ought to be able to extract this élan vital from a living organism, killing the organism in the process, and inject it into something non-living, like a rock or a teddy bear. This inanimate object would then come to life. It hardly needs saying that living teddy bears don't exist, outside of stories like Winnie the Pooh and Akira, which suggests things don't work like that. Finally, the idea of a life force falls foul of Occam's razor, the rule of thumb that one should explain mysteries using as few assumptions as possible. We should only invoke a new form of energy if we really have to, if all attempts to explain life using known phenomena have failed. The enormous progress made over the last few centuries in our understanding of life's inner workings suggests we do not need to assume the existence of anything truly new. Nevertheless, vitalism has proved peculiarly difficult to shake. It appeals to our deepest intuitions, even when we should know better. As late as 1913, the English biochemist Benjamin Moore was advocating for biotic energy, which was little more than a rebranding of vitalism. In his book, The Origin and Nature of Life, Moore drew an analogy with the then newly discovered phenomenon of radioactivity, arguing that if atoms could possess new, strange forms of energy, so too could living matter. The only answer to this special pleading is to ask for direct evidence of these new energy properties. None has ever been forthcoming. However, it seems clear why vitalism holds such instinctive appeal. We all have a sense that there is something special and precious about life, and we are reluctant to accept any idea that threatens to take that away. There is something seemingly cold and dehumanizing about the idea that there is nothing remarkable about living matter. The thing is, life energy is not the only way we can imagine living matter as special. Modern science strongly suggests that living matter is made up of exactly the same atoms as non-living objects, like rocks and scented candles. Instead, what is special is the way these atoms are arranged, and in particular, the patterns of motion they perform. An elephant may contain nothing more than carbon and a few dozen other elements, but nobody could predict the peculiar wisdom of elephant matriarchs simply by looking at that list of chemicals. We have to look at life through a different set of lenses to appreciate what it is. The computer scientist Steve Grand put it best in his book Creation, which documents his attempt to make artificial life in a computer. Life is more than just clockwork, even though it is nothing but clockwork. Today, the idea of a life force is common in alternative medicine. It's often dressed up as ancient wisdom, such as the Chinese concept of qi, which is supposed to underlie acupuncture. Oddly enough, vitalism also clings on in science fiction. The Time Lords in Doctor Who possess regeneration energy, which allows them to reshape their bodies after suffering a terminal injury. The show presents this idea literally. In the 2013 episode, The Time of the Doctor has run out of regeneration energy and is close to death, until he receives a top-up that allows him to regenerate. Doctor Who is not exactly known for its scientific accuracy, but the much harder-edged Babylon 5 also used the trope, in the form of a machine that could transfer life energy from one person to another. These ideas have a veneer of futurism, but in fact they are deeply primitive. Even if some people saw through vitalism, there was a second reason for science to ignore the origin of life. It was widely believed that life forms all the time, from dead matter. This idea of spontaneous generation is another one that recurs across many cultures, from Christianity
Sample complete. Ready to continue?